When installing conduits in commercial spaces, it's crucial to consider the potential for physical damage. According to the 2020 National Electrical Code, or NEC, conduit used in areas subject to physical damage must be Schedule 80 polyvinyl chloride, or PVC, which is also known as Type 1 PVC, or rigid metal conduit, also known as RMC. In this scenario, where 3 1-inch PVC conduits emerge from the slab, go up the outside of a wall, and enter a panel in a hallway leading to bathrooms and a janitor's closet, the decision to use Schedule 80 PVC is based on several factors. Firstly, the hallway itself experiences foot traffic and potentially wheelchair traffic due to the handicap-accessible bathrooms. This creates an environment where the conduits are susceptible to impact and physical damage from passing individuals and mobility devices. Secondly, the bathrooms, including the handicap-accessible stall, also present a risk of physical damage to the conduits. Wheelchairs and other mobility aids maneuvering in these spaces could inadvertently come into contact with the conduits, leading to damage if they are not adequately protected. Thirdly, the conduits emerging from the slab are inherently subject to movement and vibration. Over time, this movement can weaken the conduits, especially if they are not properly supported and protected. Therefore, using Schedule 80 PVC is a preventative measure against such weakening. Given these factors, it is recommended to use Schedule 80 PVC conduit for the conduits emerging from the slab and running up the outside of the wall in the hallway. Schedule 80 PVC is designed to withstand greater physical stress and impact compared to thinner walled conduit options. This provides a higher level of protection for the electrical wiring within the conduits and ensures compliance with the NEC requirements. Now let's delve deeper into understanding the NEC requirements and how they apply to this specific situation. The NEC addresses the protection of electrical wiring in various articles. These articles outline the acceptable methods for protecting conductors from physical damage, environmental factors, and other potential hazards. The NEC specifies that raceways, including conduits, must be installed in a neat and workmanlike manner. This means that the conduit should be properly supported, secured, and installed in a way that minimizes the risk of damage. When determining whether an area is subject to physical damage, it's essential to consider the likelihood of impact, abrasion, or other forms of physical stress that the conduits may experience. Factors such as the level of foot traffic, the presence of heavy equipment, and the potential for accidental contact should all be taken into account. In areas where physical damage is a concern, the NEC requires the use of raceways that are specifically designed to withstand such conditions. Schedule 80 PVC and RMC are two common options that meet this requirement. Schedule 80 PVC is a thicker-walled version of standard PVC conduit. The increased wall thickness provides greater impact resistance and makes it more suitable for use in areas where physical damage is a concern. RMC, on the other hand, is a steel conduit that offers excellent protection against physical damage. It is often used in applications where the conduits are exposed to severe impacts or abrasion. When selecting the appropriate type of conduit for a particular application, it's essential to consider the specific environmental conditions and the level of physical stress that the conduits are likely to encounter. In some cases, it may be necessary to provide additional protection, such as installing guards or barriers to prevent accidental contact with the conduits. In addition to the NEC requirements, local building codes and regulations may also have specific requirements for conduit protection. It's important to consult with local authorities to ensure compliance with all applicable codes and regulations. Proper installation practices are also essential for ensuring the long-term reliability and safety of the electrical system. Conduits should be securely fastened to walls or other support structures using appropriate hardware. The spacing between supports should be in accordance with the NEC requirements and the manufacturer's recommendations. When bending conduits, it's important to use the correct bending tools and techniques to avoid damaging the conduit. Sharp bends or kinks in the conduit can reduce its strength and make it more susceptible to damage. After the conduits are installed, they should be thoroughly inspected to ensure that they are free from defects and that all connections are tight. Any damaged or defective conduit should be replaced immediately. Regular maintenance and inspection of the electrical system are also important for identifying and addressing any potential problems before they become serious hazards. Conduit should be checked periodically for signs of damage such as cracks, dents, or corrosion. Any damaged conduit should be repaired or replaced promptly. In summary, the use of Schedule 80 PVC conduit for the conduits emerging from the slab and running up the outside of the wall in the hallway is a prudent and NEC-compliant decision. It provides adequate protection against physical damage from foot traffic, wheelchairs, and other potential hazards. By following the NEC requirements and implementing proper installation practices, the electrical system can be made safe, reliable, and compliant with all applicable codes and regulations. Now let's explore some additional considerations for conduit installation and protection. One important aspect is the proper support of the conduits. The NEC specifies the maximum spacing between conduit supports, which varies depending on the size and type of conduit. For example, for 1-inch Schedule 80 PVC conduit, the maximum support spacing is typically 5 feet. However, it's essential to consult the NEC and the manufacturer's recommendations for the specific support spacing requirements for the type of conduit being used. Proper support is crucial for preventing the conduits from sagging or becoming damaged due to their own weight or external forces. Support should be securely fastened to the wall or other support structures using appropriate hardware. Another consideration is the protection of conduits from environmental factors such as sunlight and moisture. Prolonged exposure to sunlight can cause PVC conduit to become brittle and degrade over time. To protect PVC conduit from sunlight, it's recommended to use conduit that is specifically listed for outdoor use or to apply a protective coating. Moisture can also damage conduits, especially metal conduits, causing them to corrode. To protect metal conduits from moisture, it's recommended to use conduits that are made of corrosion-resistant materials such as galvanized steel or aluminum. In addition, it's important to ensure that all conduit connections are watertight to prevent moisture from entering the conduits. When running conduits underground, it's essential to bury them at the proper depth to protect them from physical damage from vehicles or other equipment. The NEC specifies the minimum burial depth for different types of conduits, which varies depending on the location and the type of traffic that the area is subject to. For example, for conduits buried under driveways or parking lots, the minimum burial depth is typically 18 inches. It's also important to protect underground conduits from sharp objects or rocks that could damage them. This can be accomplished by encasing the conduits in concrete or by using a protective sleeve. When running conduits through walls or floors, it's essential to seal the openings around the conduits to prevent the spread of fire, smoke, and gases. The NEC requires the use of approved fire-stopping materials to seal these openings. Fire-stopping materials are designed to expand when exposed to heat, creating a barrier that prevents the passage of fire and smoke. When working with electrical conduits, it's important to follow all safety precautions to prevent electrical shock or other injuries. Always energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not familiar with electrical work, it's best to hire a qualified electrician to perform the installation. In addition to the specific requirements for conduit protection, the NEC also contains general requirements for the installation of electrical wiring. These requirements cover topics such as conductor sizing, overcurrent protection, grounding, and bonding. It's essential to be familiar with these general requirements to ensure that the electrical system is installed safely and correctly. The NEC is a complex and comprehensive document, and it's important to stay up to date with the latest revisions. The NEC is typically updated every 3 years, and each revision includes changes and updates to the requirements. To stay informed about the latest changes, it's recommended to attend training courses or seminars on the NEC. In conclusion, the proper protection of electrical conduits is essential for ensuring the safety and reliability of the electrical system. By following the NEC requirements and implementing proper installation practices, you can protect the conduits from physical damage, environmental factors, and other potential hazards. This will help to prevent electrical shock, fire, and other accidents. Always consult with a qualified electrician if you have any questions or concerns about electrical conduit installation or protection. And remember to always prioritize safety when working with electrical equipment. Now let's consider some specific scenarios and how the NEC requirements would apply. Imagine a situation where the conduits are located in a manufacturing facility where heavy machinery is used. In this case, the conduits would be subject to a high risk of physical damage from forklifts, cranes, and other equipment. Therefore, it would be essential to use RMC or Schedule 80 PVC conduit and to provide additional protection, such as installing bollards or barriers to prevent accidental contact with the conduits. Another scenario is where the conduits are located in a corrosive environment, such as a chemical plant or a wastewater treatment facility. In this case, the conduits would be subject to corrosion from chemicals and moisture. Therefore, it would be essential to use conduits that are made of corrosion-resistant materials, such as stainless steel or fiberglass. In addition, it would be important to apply a protective coating to the conduits to further protect them from corrosion. In a healthcare facility, such as a hospital or clinic, the conduits must be installed in a way that minimizes the risk of electrical shock to patients and staff. The NEC has specific requirements for electrical wiring in healthcare facilities, including requirements for isolated power systems and ground fault protection. It's essential to be familiar with these requirements when installing conduits in healthcare facilities. In a school or a university, the conduits must be installed in a way that protects students and staff from electrical hazards. The NEC has specific requirements for electrical wiring in schools and universities, including requirements for tamper-resistant receptacles and arc fault circuit interrupters. It's essential to be familiar with these requirements when installing conduits in schools and universities. In a residential setting, the conduits must be installed in a way that protects homeowners from electrical hazards. The NEC has specific requirements for electrical wiring in residential settings, including requirements for ground fault circuit interrupters and smoke detectors. It's essential to be familiar with these requirements when installing conduits in residential settings. When installing conduits outdoors, it's essential to protect them from the elements such as sunlight, rain, and snow. The NEC has specific requirements for outdoor wiring, including requirements for weatherproof enclosures and corrosion-resistant materials. It's essential to be familiar with these requirements when installing conduits outdoors. When installing conduits in hazardous locations, such as areas where flammable gases or vapors are present, it's essential to use conduits that are specifically designed for use in hazardous locations. The NEC has specific requirements for electrical wiring in hazardous locations, including requirements for explosion-proof enclosures and intrinsically safe circuits. It's essential to be familiar with these requirements when installing conduits in hazardous locations. When installing conduits in underground applications, it's essential to protect them from physical damage and corrosion. The NEC has specific requirements for underground wiring, including requirements for burial depth and corrosion protection. It's essential to be familiar with these requirements when installing conduits underground. The NEC provides a comprehensive set of guidelines for electrical wiring, and it's essential to follow these guidelines to ensure the safety and reliability of the electrical system. Always consult with a qualified electrician if you have any questions or concerns about electrical conduit installation or protection. And remember to always prioritize safety when working with electrical equipment. By understanding the NEC requirements and implementing proper installation practices, you can protect electrical conduits from physical damage, environmental factors, and other potential hazards. This will help to prevent electrical shock, fire, and other accidents.